Hi guys, I want to talk about exception handling, specifically loop, break, and continue inside a try, except, finally block. Recall that in a try statement, the finally clause always runs. The try block lets you test a block of code for errors. The except block lets you handle the errors. The else block executes if there is no error. And the finally block lets you execute the code regardless of the results of the try and the except blocks. So let's try writing some code. Try print x except print an exception occurred. Let's run this and see what happens. It printed an exception occurred. It did that because x was not defined. So that was a very, very good illustration of why we use try except. The try statement will generate an exception whenever we have names that are not defined. Since the try block raises an error, the except block is executed. Without the try block, the program crashes and raises an error. We'll illustrate an example of this. Print x. Let's run it. Name error. Name x is not defined. So notice the same statement did not throw an exception up here because we were handling the exception. We used the except statement. Excellent. So in general, when a Python script encounters a situation it doesn't know how to cope with, it raises an exception. An exception is actually a Python object that represents an error. If you have suspicious code that you think you may have problems with, you might want to use a try statement. So there are different kinds or ways of structuring try statements. You can have specific except statements where you actually name the exception. You can have general except statements that are basically catch-all, or you can have else statements that are saying execute this code if there is no exception. So let's try writing some more code. So we are going to, we're executing a try. We print x. Now, if it throws the name error exception, it will run this code. And if it does not throw an error, it will run this code. Variable x is not defined. So excellent. It actually, we handled that error, and we are able to use a specific exception. Those are very, very useful. And you can actually have multiple exception statements. You don't just have to have one. So let's try an example where we don't generate an exception. So try print hello, except print something went wrong, else print nothing went wrong. So what's going to happen? So it printed hello. There was no exception, so it skipped over the except. And then because there was no exception, it ran the else. So very good. So it can be useful to actually close objects or perform cleanup using very similar statements. So let's try something. So try f equals open demo file text. F write lorem ipsum, except. So if there's an exception, if it's unable to open the file or unable to write, it will print something went wrong when writing to the file. Finally, print run code to close the file. So let's try this. What's going to happen? So there was an exception thrown. It did not, I believe it was not able to define F properly. So it ran the exception code, and then it ran the finally code, which it would run whether there was an exception or not. Okay, that was very useful to learn about exceptions. So let's see if the finally statement will always run. So here we have a equals 10, b equals 1. We're going to try a divided by b. So that would be 10 divided by 1. If there's an exception, it will run this code. If there's not, it will print. This is always executes. So let's try it. This always executes. So it ran the finally statement. Let's try another version of that. A equals 10, b equals 0. We may have a zero division error. Or will it run the zero division error, or will it run finally? Remember, it will always execute the finally statement. So it actually executed the exception, and then it executed the finally. Very good. What happens if we have a while loop with a try, an except, and a finally statement? So if it has all of that, so here we have a equals 0, b equals 2, while a is less than 3. So we're printing this line, this horizontal line. We add 1 to a, and we subtract 1 from b. Now we have a try statement. We're assigning a variable. It's a divided by b. So a divided by b will be 1 divided by 1. And it will throw an exception if there's a problem with that. If there's not a problem with that, it will come down here. And that's exactly what it does. So let's try it. So the first iteration of the loop, we had 1, 1. We had 1 for a and 1 for b. The second, we had 2 for a and 0 for b. So it actually threw the exception, division by 0. And then remember, it always executes finally. So it executed the finally. The third iteration, a is 3, b is -1. So we actually, because there was no exception, did not run the exception code. It went down finally, and it went down to the main loop. And here's the main loop. So that was excellent. So let's try using a break. We're going to copy the same code, and we're going to try a variation. So here we have the continue, and I want to point out that the finally code executed even though we had continue. It still dropped down to the finally. So let's try a variation on this. What we're going to do is we're going to replace continue with break. And we're going to see what happens. Now we run it. So so what's happening is it's running the first 2 iterations. So this always executes, main loop, and division by 0. So very good. So let's try one last version of this. So here we have a equals 1, b equals 3, while a is less than 3. So we're going to start with, we have 1. Let's see. We have 1 and 3, and then we'll add, and then we'll subtract. So we have 2 and 2. The first iteration, and then we have 3 and 1 the second iteration. So it looks like it is not going to throw an exception, so let's try that. So this always executes main loop, this always executes main loop, no errors found. Excellent. So let's try one last version of this code. So here we have a is 1, b is 6, and then after it makes the changes here, makes the assignments, we have 2 and 5, and then we're going to have 3 and 4. So it is not going to throw the exception. We are going to be running finally, and we will run the outer loop without an exception. So let's run it. So we have 2.5 always executes, 2.5 main loop, 3.4 always executes, no errors found. Excellent. I really enjoyed this. I love these type of loops, and exception handling is really, really important. If you've been a programmer, you realize that exceptions that are not handled are the bane of users. When the software crashes, and you're going to be getting a lot of angry phone calls. So this is really, really important stuff. Thanks, guys. It was great.